Welcome to this episode where I talk about the second item of my recipe for carefree dependency management in Java project, which is version management. One aspect we have touched in the last two episodes is using open source third-party modules. One thing we have to deal with when we use these modules compared to our own modules is version selection, as each third-party module exists in multiple, sometimes hundreds of versions. We saw that Java itself does not have any version management. The Java module system can detect if I have two versions of a module on the module path, but it can't help me with selecting a version or downloading the module of a certain version. That is why we want to use additional dependency management tooling, which is part of the build tools Gradle and Maven on top of Java, even if we use the Java module system. The first thing a tool should do for me is downloading the module and putting it on my module path or class path. In the last episode, we saw that both tools can download modules from so-called Maven repositories, like Maven Central. In such a repository, the jar files that represent the modules are located in a certain structure and have additional metadata. When we look more closely at the structure, we see that the version is always part of the location of a module. So to locate a module in a repository, a tool first needs a unique identifier, which are the coordinates consisting of group ID and artifact ID, and a version to select one of the many available versions before actually downloading metadata and jar file. That's why I, as a developer of a project in which I would like to use these modules, I need to decide for a version. Last time we looked at the different options to declare dependencies to modules. I may have dependencies to my own modules and dependencies to third-party modules. And for each third-party module, I need to select a version. Now we have already established that version management is something the dependency management or build tools do. It's not a feature Java itself offers. That's why the information about versions is done in the notation of the build tools. Even if you use the Java module system, there is no feature to add a version to the module info Java file or any other Java file. This means even if you use the module system and keep your build Gradle or POM XML files mostly empty, the versions still have to go somewhere in a build tool native notation. In Gradle, you currently have multiple options to do this, but one option that is very similar to what is supported in Maven and that works well together with the module system is using a so-called platform. The platform concept in Gradle is based on a concept originally introduced in Maven, which is a so-called bill of materials, or BOM in short. This is a piece of metadata, so concretely a file, that contains information about versions and only versions. It doesn't state anything about which modules you actually want to use as dependency somewhere, but if you use a module as dependency, then this file can give you the version information for that module. It has the advantage that you always use the same version information in a multi-module project, even if you declare a dependency to a certain modules in multiple places. You can do that in Gradle by having a separate build Gradle file for this. In this setup, I put this file inside a versions folder inside the Gradle folder. The Gradle folder is also the place where we will put all additional build configuration, which is something that we'll talk more about in the next video. So in this build Gradle file, we first use the so-called Java platform plugin. As in Gradle, we say what a file or a component is by applying plugins. See my video on that topic. And then we have the possibility to define so-called dependency constraints. These constraints are just a list of versions that you want to use. Here you use again the group ID artifact ID notation to refer to a certain module and the version. Note that even if we use the module system, here we use the group ID and artifact ID notation to refer to a certain module and not the module name, because the group ID artifact ID combination is what Gradle natively supports and what also other tools understand, about which we will talk when we get to the point about keeping dependencies up to date regularly. In this example, we define a version for Commons.io and Commons CSV, because these are two modules we use directly in our dependencies in some of our modules. If we would not define all the necessary versions, Gradle will complain that it can't download a module or can't find a module, as without the version it can locate nothing in the repository. Note that here we can also define versions for dependencies that we only get transitively. An example of this would be Commons Codec. This is sometimes good if we want to control this, for example, update the transitive version on our own. But for working software, we do not need to define all these versions, because as you may remember from last time, the metadata of the modules we use directly may contain version information about the transitive dependencies, which is also used by the tools. Then sometimes you want to define a version for multiple modules that are part of the same libraries and all have the same version. In our example, this is the case for LWJGL and for SLF4J. Often such libraries offer a published BOM themselves. Published BOM means the information I put into a file like this one is published to the repository as well. You'll then have an entry in the repository that only contains metadata and no jar file. In the Gradle platform concept, we can define a dependency to an existing BOM, which means the information from this BOM is used as well. So we do that for the LWJGL BOM and the SLF4J BOM, and also the JUnit 5 BOM that we use for testing our software. The testing part is not seen here in my visualization, but it is part of the example sources which you can get from the link in the description. If we define our project in Maven instead of Gradle, we have similar concept in the mentioned BOM or bill of materials. This is a separate POM XML file in Maven, and it contains the dependency management block, which is conceptually similar to the dependency constraints block we saw in Gradle. And here we now have entries for the versions we want to define, similar to what we just saw in Gradle. Only that here the Maven XML notation is used. Then also in Maven we can use existing BOMs. In Maven this is also done inside the dependency management block, but the corresponding entries contain the type POM and scope import tags. That is because in Maven we do not talk about defining dependencies to published BOMs, but about importing published BOMs. The type POM comes from the fact that the published BOMs only contain of the POM XML file and do not contain a jar file, which is the default for all other dependencies. One difference we can see between the Gradle and the Maven file is that there are different versions for Commons IO defined. You may remember that in our example we have a version conflict. Originally at least, we said we wanted to use version 2.16.1 in our own source code. But then when we also use Commons CSV, another version of Commons IO is required by Commons CSV itself, which is the higher version 2.18. If we don't use this higher version, we got a missing class error. Now in Gradle we don't necessarily need to update the version ourselves, because Gradle looks through all version definitions in the whole dependency graph. By that, it will find the higher version that was mentioned in the metadata of Commons CSV. We looked at that in the previous video. And then by default, Gradle will select the higher version. We'll get into more detail on this when we get to the point of version and capability conflict management, which is the fourth item in the recipe. In that episode, we'll also talk a bit more about the differences between Gradle and Maven in this area. In short, what happens here is that Maven always takes the version you define over any version that comes from transitive dependencies. So in order to get the 2.18 version, which we need to update our own definition. In summary, what we see is that we can have a separate dedicated file for versions in Gradle or in Maven. So no matter which build tool we use, or if we use the module system or not, we have the version information centralized. We have for one separated it from the dependency declaration and can declare dependencies to a module in multiple places without repeating the version. And we have a consistent setup where we know where to find our versions, which makes it easier to manage them and update them regularly. The topic of regular updates is also one item we'll talk about in one of the next videos. How we make sure that the version information file is used in all of our modules is part of the next episode, where we talk generally about separating build configuration from the places where you define dependencies. If we run one of the build tools, it is able to download the modules we need based on all the information it has, compose the class path or module path, and run or package the application for us. Where we put the configuration for the build tools for doing this running, packaging, or testing of our software without interfering with the dependency management and module dependency declarations is what we look at in the next video. See you then.